Hi, I'm Jason.
And I'm Alison, and we're grad students at the University of Hawaii Institute for Astronomy.
We're here from Mauna Kea Observatories at Home to give you a walking tour of our solar system. We're going to start our tour here at the Sun, go through our terrestrial planets, out to the outer solar system and the Jovian planets, and eventually down the street to visit the outer edges of our solar system.
We start our tour with the Sun. The Sun is so massive, it has 99.8% of the total mass of the solar system just in this one object. And it's so large that you could fit 1,000,000 Earths inside of it, or 100 Earths across. And it's the source of essentially all energy in the entire solar system comes from the Sun. The next stop on our tour is planet Mercury.
Mercury is the smallest planet in our solar system, at only 1.5 times the size of Earth's moon. It's so close to the Sun, in fact, that it's tidally locked, which means that the same side of Mercury always faces the Sun. It's also interesting in the fact that Kepler's laws don't adequately describe its orbit, and we need Einstein's general relativity to predict future orbits. From Mercury, we move on to Venus, the closest planet to Earth.
So not only is Venus the closest planet to the Earth, it's also very similar in size, which is why some people call it Earth's twin. However, its climate is very different. Because of all of the carbon dioxide in its atmosphere, it had a runaway greenhouse effect, and its temperature is 900 degrees Fahrenheit. Moving on from Venus, we get to visit my favorite planet, Earth.
Earth, like the rest of the solar system, is about 4.5 billion years old, but us humans have only lived here for about 200,000. Earth is also unique in that it's the only terrestrial planet with abundant liquid water on its surface and a strong magnetic field, which is why we exist in the first place. The last stop in the inner solar system is the planet Mars.
Mars is home to the largest volcano in the whole solar system. It's called Olympus Mons, and it's the same type of volcano as Mauna Kea, Mauna Loa, and Haleakala. It also has polar ice caps, and it's the only planet where we have active rovers. Now it's time for us to leave the inner solar system and embark on our trip to the outer solar system, the first planet of which being Jupiter. Now we're just gonna skip over the asteroid belt.
Jupiter is the largest and most massive planet in our solar system, more massive than all the other planets combined. Its 4 largest moons, otherwise known as the Galilean moons, were definitive proof that Earth is not the center of our solar system and other objects don't revolve around the Earth. Jupiter is also famous for its Great Red Spot, which is a large hurricane larger than the Earth itself. From here, we move on to Saturn.
Saturn is probably best known for its rings, but they haven't always been there. In fact, had the dinosaurs been able to look up at the night sky and see Saturn when they were living on the Earth, they wouldn't have seen rings because they've only developed recently. Saturn is also noteworthy because of 2 of its moons, Enceladus and Titan, are very promising candidates for harboring life in our solar system. Another interesting fact about Saturn is that its average density is less than that of water, which means that if you could put it inside of a giant fish tank, it would actually float to the top. Before we venture out into the outermost regions of the solar system, let's take a look at how far we've come.
Uranus, like Saturn, also has a set of beautiful rings. These tell us that it rotates perpendicular towards the direction of its orbit, unlike any of the other planets in our solar system. Also interesting is that anomalies in the orbit of Uranus allowed astronomers to predict the location of our next planet, Neptune.
We have arrived at Neptune, our final planet, but we're missing some supplies. Because Because Neptune is so far away, that means that the time that it takes to orbit, that is a Neptune year, is 165 times longer than an Earth year. That means that because Neptune was only discovered in the 1800s, it celebrated its first Neptune anniversary of being discovered just 10 years ago in 2010. Also, it's noteworthy because it has a moon Triton that orbits in a direction opposite to everything else in the solar system. And this is because it was captured by the gravity of Neptune.
Hi guys, I'm Zach. I'm here at the Pluto-Charon system over 3.5 billion miles from the sun. That's almost 40 AU. Now you might be wondering, why isn't Pluto a planet anymore? And in 2006, the International Astronomical Union decided on 3 criteria that should be used to decide whether something is a planet or something else. First of all, planets should be spherical, which you can see Pluto is basically spherical. Second, planets should orbit the sun and not some other object. Now, Pluto does orbit the sun once every 248 years. Third and finally, a planet should clear its orbit of debris. Now, Pluto doesn't meet this criterion, and since it didn't meet all 3, it was promoted from a planet to a dwarf planet. Now, besides Pluto, out beyond Neptune, there are a few other dwarf planets, including Eris, Haumea, Makemake, and Sedna, just to name a few.
Hello everyone, my name is Erica and I'm a graduate student at the Institute for Astronomy. You've reached the end of your journey at the edge of the solar system. And for reference of what we've left behind, right here is the inner solar system with all of the planets and the fuzzy region on the outside being the Kuiper Belt, which is where Pluto and other dwarf planets are. Now the Oort cloud, in comparison, is this icy spherical graveyard of material that ranges from about 1,000 to hundreds of thousands of AU across. Now, for reference, 1 AU is 93 million miles, so that's quite a road trip we're talking about to get out here. Now, this region was created during the early solar system when a lot of material was scattered outward as a result of many different events. Sometimes, when stars get too close to this region, some of the material is gravitationally disturbed and gets sent flying back inward into the inner solar system. These objects are what we refer to as long-period comets.
Well, that's the end of our tour. Thanks for joining us. If you learned something new, let us know in the comments. For more Mauna Kea Observatory's videos, like and subscribe. I'm Jason.
I'm Alison. Stay safe out there and mahalo.